Okay, thank you very much, everyone, for joining. So today and tomorrow, we are going to see how to handle errors in MuleSoft. Why is even error handling important, or what is error handling? What are the different approaches to handle errors and the different types of errors in MuleSoft? So we'll spend 1 hour today, 2 hours tomorrow. So by the end of class tomorrow, I hope everyone will understand the different scenarios and be able to answer any kind of, be able to answer the error handling questions that can come up in the certification exam. So as usual, I have the project that we are going to see today. We will have more hands-on demo. So I have multiple flows and added the project to GitHub. So after the class, you can download it and rerun it and try to understand, review what we did in class. So if you remember, when we started, I think this was in week 3, we talked about Mule for event structure, and we said Mule for event has a couple of components. One is, we have this one, the message, and under the message, we have a payload and attributes. We have been working with payload and attributes multiple times by now. So you know what payload and attributes are. Payload is the data that the app processes, and the attribute is metadata about the payload. We saw our query parameters, URI parameters under attributes. And when we read in files also, the file name, when it was last modified, and so on and so on. Such kind of information about the main data are attributes. So attributes and payload are part of a message. And also the other component we saw are variables. And we created different kinds of variables using set variable and also transform message. And we saw how to access variables using vars.variable name. And the last component that you see here that we are talking today and tomorrow is this exception message, or the error. How do we handle the error? So when an error is created in a Mule event, then it creates an error object. What are the different components of an error object? How do we customize it? How do we customize it so that it is more intuitive to the user? Or how do we handle it so that we can continue processing without our application failing, and such kind of things we are going to discuss. So to give you first, to give you to motivate this concept, or to give you a background, let's just see one of the applications we built before and try to introduce errors to it. Because so far we were assuming, like when we create an application that expects a query parameter or a URI parameter, we were passing the required inputs without any errors. But if you don't, like for example, if it expects a URI parameter, and if you don't include a URI parameter, or in the query parameter, if it expects string but you pass it a number, or if it expects a number and you pass it string, then how do we handle such kind of errors? So I have this one. Let me close this. So I have multiple flows here that we are going to experiment today and tomorrow, and also I have multiple questions. So I hope everyone will understand all the different scenarios. So this one is one of the flows that we built in the previous classes. So what are we doing here? We are updating the customer table. We have customer, let me show you here. We have this customer. This is the data from Dowley 3 schools. So if I just run it, it gives me the customer's data. We have 91 rows. We have been working with this data. If you have not imported it to Workbench, you can get it from the data GitHub repo. So this application, what it does is, what it expects is, let's see if we start from here. So this is a path, and in here we are updating for a given customer ID, we are updating the CD, country, address, and the postal code. And one application of such cases we said could be if the customer moves to a new location, then we may want to update it. So for this one, as you can see here, it expects, let's see what it expects. It expects under the attributes, we have query parameters. So it expects CD, country, address, postal code, and customer ID to be passed as query parameters. Now, what happens if we don't pass a query parameter, if we don't pass all these query parameters, or if we pass them incorrectly? Let's see. Let me make sure this is running. Let me run it in debug mode, stop this, and run it in debug mode, and prepare in Postman. So we have Postman here. So the path is update customer, then I'm specifying the customer ID. Let's say, for example, customer ID 1, the country is Germany, CD Berlin, we have this postal code and this address. So let's assume now this user moved to the US recently and we want to update it. So that is what I'm doing here, customer ID 1. Then I have some address, some postal code, and some country. So for this customer ID, change the address to this value, the postal code to this value, and the country to this value is what we are doing in the flow. So I think it is ready. Clear this. And let me add a logger here. And and we have this message, table successfully updated. So if I send this request now, if I send it and come here, as we have been looking at, we have under attributes all these query parameters. They should be, we have 4 query parameters, and so we are accessing them here. So if I click next, remember it is a customer ID 1. Right now in the table, it is in Germany, Berlin. But now, after I finish this and come to Workbench and rerun this, you will see CD is not for some reason, but postal code, country, and address have been updated. Did I provide CD? Or maybe I didn't include it. So that's why it is not. So here and CD is DC, for example. So I can do like this and come here, click next. So if we come now and rerun this, so you see it has been updated. The address, the CD, and postal code in the country has been updated. But usually when we build applications, we should handle errors robustly. So for example, one way to handle errors is if someone, for the customer ID, if they pass an alphanumeric or something that is not integer, we should tell them that customer ID should be an integer. Or if they didn't provide all the address information, then we tell them that if you don't, this address are missing, so do provide them. And I have an a flow below is that does that. So if you come here, let me scroll down. Is this one. So under modules, you can see there is a validator module. So here, let's see validator. So under validation, under validation, there are different things that we can validate. For example, is number is one. For the customer ID, we can use is number and specify what number it should be, whether it is integer or decimal, which is double. We have is time, is null. Is null means empty. Is not null means it is not empty. So we have all of these things. We'll see them one by one. Now I have a modified version of the upper flow that you see here. I have all these validations. So from the query parameters, I'm creating variables here that you can see. So we have seen before that we can create multiple variables using transform message. That's what I have done here. Simply click this add, and here select variable, give it a name, and provide its value here. So we have all these variables: CD, country, address, postal code, customer ID. If we don't pass them, then in the query parameters, then they will be null. So the first thing that I'm checking here is I have this is number validator. So actually this transform message, in this case, I don't need it because I'm using query params.customer ID directly here, or I can use vars.variable name for customer ID. So this one, what it does is I'm asking it to check if this one is a number, and the number type also we specify it here. We have float, integer, long and short. So here I'm telling it to check if it is an integer. If it is not an integer, it should tell me that the customer ID should be an integer. That's what I have here. Customer ID should be an integer. However, what you passed is not an integer. So it should pass such kind of message than more generic errors, or rather than simply saying it failed, or more not clear error message. We should handle it in such a way that it is very helpful to the user. So this one, let me send and show you what it does. So the path is update customer 2. So come here, just change, add to the path 2. Now, let's change the CD here, Baltimore. So the first time it should work because I'm giving address, everything here is as expected, the data type. So I will send. So it says table successfully updated message is what I see here. If we come to the table to workbench, the CD, which is DC right now, when I rerun it, it should change to Baltimore. So if I click run, you see it has been changed to Baltimore. Now let's get back to here, and the customer ID, rather than just one, let's put maybe a BC or some alphanumeric, something that is not integer. So let's see what I get. So it comes here. Oh, yeah, it is because I ran it in debug mode. So when it encounters an error, it stops. But yeah, without debug mode, let's run it and see the response right away. So in this case, we are going to check. What happens if the customer ID is not a number, or any of these attributes. If they are not provided, it should tell us to provide the right data type. So this should give you context to what error handling is. There are different types of error handling, but one reason that we handle errors is so that it gives intuitive responses. And there are different types of errors, and we may want to handle each error separately, customize them. Or even if there is an error, we may want to skip the error and continue processing. For example, let's say you want to add numbers in an array, and the array has numbers and letters. So you want to skip the letters and just add the numbers. So in that case also, we have to handle the errors appropriately so that it doesn't fail or it doesn't stop when it gets a non-number value. So this one has been deployed. Okay, send again. So you see, customer ID should be an integer. However, ABC is not an integer. So when it gives me this error message, I understand what my mistake is. So I can go and fix it. Now, let's say we forget entering CD information. Then it should tell me that CD is not there. So if I click next, it says CD should be provided. So if I change the other query parameters, also the same thing, it will tell me to provide them. So that is one way we can handle errors. And how are errors handled in MuleSoft is what we are going to see with the different types of errors and the response in each one of them. So if I get back to the slides, in here, we see there are two types of errors. One are the system errors. The system errors, they happen when we try to deploy our application, on application startup, or when a connection to an external system fails. These are the system errors. But what we are mainly interested in, and the errors that we can customize and handle, are called messaging errors or Mule errors. So these are the types of errors that we are talking about. So far, I'm sure you have encountered different types of errors. Now, maybe at that time when you first encountered errors, you were overwhelmed. Now, after you understand their content and what they mean and so on, and the different types, I think this will be more clear. So first thing, let's talk about components of Mule errors or messaging errors. So it has different components, but we are mainly interested in two of them. So we have the description, this one, error description, and we access it by using error.description in our data weave code, because it creates, when an error happens, then it creates an error object. It contains different data, different information under it, and one of them is the description. We access it using error.description. The other one that we are interested in is the type, this one. So we access it using error.error type. This one is the first one, the error description is some it is string, whereas this one is an object. It contains more information. Now let's get back to MuleSoft and see sample errors by creating errors in our applications. By the way, this application that I'm using to, where is it? Did it disappear? Yeah, this one, annotate. I like it. If you use Google Slides for something, and if you want to use this one, just message me and I will send you resources on where you can get it. Okay, so let's get back to Endpoint Studio and introduce different types of errors. So let's see I will move this up so that we can have, you can see only this one. This one is one of the flows we created before. So what it does is it reads CSV data, this one, airports.csv data, and we transformed it to JSON, and it sends the data in JSON format. So I guess from now on, let me switch again to debug mode so that we see the error as it propagates and its contents one by one. So what I'm going to do is, first I will show you the results while it is working by just reading this airports.csv data that we have been using, and I will change the file name to a file that doesn't exist, and at that time it should give us an error. And what type of error does it give us? What are the contents of the error? We will compare when we use different operations, different processors. For example, when reading, when connecting to an HTTP request, when trying to connect to a database, and so on. What do the errors look like? By just seeing the error message, can I tell what is happening? Is what we are trying to understand. So this one, move this here. Yeah, it is ready. So let me see, the path is read. Okay, so I will come here, remove this, and change this to read. If I do this, now I can come here. So if we come here, what do we see? There is the data, which is airports data. So now if I click this, it was CSV initially, it has converted it to JSON. That is why we see array of JSON objects. Now, if I click next processor, I should get the output here in JSON format. This one we have seen already. Now, let me change the file name to something that doesn't exist. For example, airports1.csv, and save it. Then it is going to update. Yeah, it is updating. So it is updating. Now I will send the same request and we'll see what the error looks like. So successfully reconnected. Perfect. Come and send again. Then if we come here, what do we see? We see an error object created here. See, there is error here. So under here, there is error. And under it, we see description. So the error description is, it tells the path that I provided, it says it doesn't exist. And there is an error type. There is also detailed error description. It contains, sometimes it contains more information than the description. Sometimes it is the same. Description is enough for most cases. And the error type is here. So the error type, as we said, it is an object and it contains especially two important information, the namespace and identifier. So errors are identified by their namespace and identifier. So the namespace here is, it tells the domain. So this is related to file reading. And the identifier is illegal path. So the path doesn't exist. So I can see when I just see this error message, then I have the feeling that this is related to file and the path is incorrect. And in the slides, I have added some screenshots here and here. So here are the error description is here. It is a string and the error type is an object. As you see, the error type, we can check here. If we just come to this data evaluator and write output application JSON, and you can see the output. It gives us this file. As you can see, it has the namespace, which is file, and the identifier is the illegal path, and it gives us a parent also. We'll see those things in the next slide. So this is one kind of error. Quickly, let's see other types of errors and see how their namespace and identifier are different from what we see here when we try to read in a file that doesn't exist. So I will exit this, and I have another one here, a request. This one, I'm sending a request to an application that doesn't exist. So http.test4567 test something. So this one also should tell me that the HTTP request, the path, the connection doesn't work. So let's check. The path is, if I come here, where is it? Here. So it is request. So I will change this to request. Now see what the error message you will get is. Come here. So you see the error, again, it has a description. It says HTTP get on resource, the path I provide, the full URL failed, couldn't resolve address. So the address, it doesn't exist is what it is saying. And under error type, we see it is HTTP connectivity. So it puts the namespace and identifier separated by colon here. So when I see this, I see it is related to HTTP connectivity, not database connectivity, for example. Another one before we move from this, looking at the error, different types of errors, let's experiment with this one. In this one, what we were doing was we are reading data from a database. So I have from my SQL, I'm just reading data from the customer's database. So this one, if I just take this path and now the request, it was HTTP connectivity. For database, when my database is offline, it should say database connectivity or something along those lines. So submit, come here. So the first time my database is working, so that is why I see data. If I click next, it will exit and the response is here. Now, let me stop my SQL. I have my SQL here. So I will stop it. Now it will not be able to connect. So let's see what error message that I will get is and how it is different from the two error types we saw so far. Send and come here. There is an error message, as you can see here. So with request, under the error type, with request, it was HTTP connectivity, but now it is DB connectivity. So this is related to database connectivity issues. So how do you handle such kind of, these are different types of errors, and what does the structure of errors look like, and so on, is what we are going to focus in today and tomorrow. So exit this and start my SQL also if I need it for any case. And let's get back to sliders. What do we have next? So this is important concept. Let's see this one. So what do we see here? When an event is being processed, so when an event, a Mule event is being processed and the big transfer from one processor to the other, or from one component to the other, through a Mule flow that throws an error, what happens? So when there is an error, what happens? One is the normal flow execution stops. After it encounters an error, it stops the next processor. It doesn't move forward. Rather, what happens is the event is passed to the first processor in an error handler. So far, we didn't set up any kind of error handler. We were using the default error handler, but with all the flows we created at the bottom, there is this error handling. So if we don't specify, if we don't customize it, it uses MuleSoft's default error handling, but we can also create our own custom error handling in a way that we want it to be set up. So remember this anyway, when there is an error, it stops. The normal flow execution stops, and the event is passed to the first processor in an event handler. If there is no an event handler that we set up, a custom event handler, then the Mule's default error handler takes care of it. So in the applications we saw in these ones, let me keep this. In here, what was happening was in each stage, once it encounters an error, it doesn't move past that line. So past that processor, I mean. In here, for example, once it tries to read the file and an error is created, then let me take this one and create. So this one, let me take a screenshot and show you what I'm trying to say. First, let me expand this. So there is no anything in that error handling block or component. Now take this to Google Slide and put it here. Let me create a new slide and paste it here. Paste. Copy. Paste. Okay. And make this full screen. And so in this case, for example, what is happening is we send a request and why is annotated disappearing? Okay, here it comes. So we send a request, then a flow is triggered. There is a HTTP listener as a source here. So a flow is triggered. Then there is read here. Probably this one I can change it to something green. So this is green. Then here there is an error. This is error. After it comes here, there is error in this processor while it tries to read the file. Then after this, it doesn't move to this component and to this component is what we are saying. Rather, the error message from here is pass it to the error handler in here to be handled. So in our error handler, if we set it up in a way that it should handle the errors and continue processing, then yes, it is going to continue processing, continue to the rest part of the components. But the default error handling, by default, what happens is the error from here comes to this error handler, and MuleSoft's default error handler propagates from here. It propagates the error to the caller. So basically, from here, the error message gets back to here. So while it tries to read a file, reading the file fails, that message comes to here, to the error handling part. That error handling part, we don't have anything in it by default. Then this error message it gets back to the listener. So let's see this setup. We can see it in HTTP listener. We have it the different configuration. We can see. Let's see, for example, let's see. We can see this one, first one. So under what do we have? Under the HTTP listener part, we have responses section. So under responses section, we have response and error response. I think I have this on the slide somewhere. Response and error response here. So which one? We have response here. This is the response part. So when it is working, if an error doesn't happen, then it sends what it should send. We put it here. So by default, it is payload. That is why when we send a request so far with the different applications we have been building, it sends the payload. The payload, if we have different components connected to each other, and if we set some payload at the end, for example, table successfully updated, that is in the last transform message, that is a payload, and that is what comes back here. If we put something else here, then our response will be what we put here. And by default, we saw the different HTTP status codes in week 2 or 3, I think. And by default, when it works fine, if there is no an error, then the status code is 200. So by default, for a success, when our application is successful, it returns a payload and a status code of 200. Whereas if there is an error, by default, the status code is 500. It is not specified here. It is just by default known. It returns 500, but we can customize it. We will see how to customize this. And it sends, the other thing is also, it returns the error description. So for an error, we get error description and a status code of 500. Whereas for success, we get the payload and a status code of 200. Now let's modify this and see what we get. So if I come back to Endpoint Studio, and this one, the payload, for example, let's write something else. I can write output application JSON. I want it now JSON. Then let's create an object. Time now is, let's say this one. So before, if it works fine, what it returns is, in here it reads a file, right? So let me remove this, make the correct data file name. So it reads this airport.csv, it transforms it to JSON. That's the final payload. There is no any payload after that. We didn't modify this payload. That is what gets returned, because by default, for success, it should return the payload in the status code of 200. But now we are modifying it in the listener here. We are modifying it to just return time. So every time we send an application, it is just going to send the time. And status code is also here. The status code, we can change it to, let's say, 234 or something. Now let me save this, and then we'll send a request and we'll see what happens. So when it works fine, when we have any kind of flow, let me take even another longer flow maybe. So I have this flow, take a screenshot and paste it here. So by default, when we have an application and when a request is sent, so what happens is this one, we say a source is here, it gets triggered. In this case, some payload is being created and we have some validator here. Let's say it passes. And after that, we are modifying the payload. That is what we see here. The payload has been modified. This logger is simply for logging whatever we put there to the console. It doesn't have other impact. So this is our final payload. So by default, what we'll get is this payload. This payload will come to here. That is what we get. And our status code will be 200. This is by default. But if we have an error, let me reproduce it again in the next slide. Oh, did I remove it? Right. Okay. So let's say now I have an error. If I have an error, and it is misbehaving in full screen, it is not working. Anyway, I will work like this. So let's say there is an error somewhere. Let's say an error happens maybe in here, in this validator. It is checking if it is a number. So if an error happens here, what happens is this part and this part will not be executed. From here, the error will propagate to this error handler, we said, and MuleSoft's default error handler will pass that error object to the source or to the caller, which is in here. Then we get, by default, we get the description and a status code of 500. But now we have modified it, and let's see what we get. So it is this application, this flow that we modified here under here under responses. So we put a status code of 234, and here the payload we have modified it to something else. Let me send a request and show you what we get. So it just read. If I do read, send, and come here, so it has stopped in the logger. Everything went successfully. That is why I see a payload here and the attributes and stuff. So click next processor. Now we get a response here. So you see the payload now is the time stamp right now. And this is the status code also is not 200 anymore. It is 234, the status code that I put. So we can modify it that way. It is customizable. Let me get this back to payload and remove this also. Now let's see, let's modify the part in here in the error response. In the error response, by default, it is description, but let's change it to the, for example, to the error type. So it will be more detailed. First, let's experiment with description itself. Description. So save this, and I will make the file name a wrong file name and send a request. Let's see if this is updated successfully. Okay, perfect. Clear the console. Now, it's because I have many flows. Send that same request. Send it. Come here. So an error has been created. And we see under is the error description and the error type. The error type is, by default, it returns this one, the error description. But now we modified it to return error type object in JSON format. So if I click this, and come back here, oh yeah, we didn't modify it. I think, yeah, the first time we said let's return the error description. So you see here, I got the error description. It gives a full path, doesn't exist. Now, and also the status code, pay the attention to the status code, 500 server error is here. Now let's go and modify it. And in here, the status code, let's make it 700. And this one, the output, let's make it application JSON type, and rather than description, error type. So save this. Okay. Clear it and send the same request. Now pay attention. This error description will now change to the error type object, and the status code also will change to the new status code we provided there. So click and submit and come here. So the description is there, error type is here, click next. So let's come back and see here. So you see our status code has changed to 700, and here it gives us, rather than the error description, it gives us the error type. So for HTTP listener, we can customize the response when it is successful, when there is an error, or when it is successful, we can customize it. But by default, what we said is, by default, it returns these things on this page. When it is successful, the payload and the status code of 100. When it fails, the error description and the status code of 500. But we can override these values for an HTTP listener, is what we see here. So let me revert this back to the default setup. If we come here, remove status code from here, and this one make error, or it was error description, and this one was plain text. So I hope this is giving you, it is helping to understand how it is returning, what it is returning, a given flow, why is it returning something. So when you see what it returns, you should be able to understand how it is configured. Okay, now let's get back to the slides. So we were here, and perfect. So we were here. So there are, we said error types are identified by namespace and unidentified. They are separated by colon. That's what we said. So we have a namespace here. That is a domain. It tells us the domain, whether it is HTTP, validation related, file, or database, and so on. And there is an identifier. So for example, so far we saw in just different flows we ran, we saw this one, HTTP connectivity. We saw this with the HTTP request. And we saw this file illegal paths when I provided a file name that doesn't exist. And we saw also this DB connectivity error when my database was offline. And this DB bad SQL syntax is when your SQL has an error. There are other types also. This is, the first one is authorization related. It could be related to, for example, when we provide inaccurate credentials or expired token and so on. And at the end, in the bottom also, we have this type is composite routing. We have these kinds of error for parallel for each and scatter gather because these routers, they process data in parallel. That is why it is composite. We see the keyword composite here. So errors are identified by their namespace, and identifier is what we see here. And as we said, rather than simply saying not found, if it is just not found, it is less informative as compared to HTTP not found or file not found. You can have these errors. Not found can be a result of either of this, or from file read, when you try to read a file, or when you try to connect some HTTP, if you have both of them in the same application. And if you just get not found, it is difficult to figure out which one of them returned this error. But if you have the domains, then you can know which of them causes the error. This diagram shows the different error types. We have general error types here. These are called general. And we have critical here. So under critical, we have fatal and overload. These error types, they cannot be handled. MuleSoft just logs the error. It cannot handle them. They are too critical. Whereas the general one is, they are under the parent any, and there are different types of them. So you see they have a hierarchy. The error messages have a parent, is what we see here. Under any, we have unknown. If the error type is not clearly known, we have this unknown here. We have transformation related, routing, connectivity, expression, and security. And under security, we see client security and also server security. All of this, we can get them from this documentation. So in here, this is very important because when we try to customize our errors, we may want to customize different errors slightly differently, or even under one parent, the different children errors under it, we may customize them differently. So here we have to understand that errors have a parent. That's what this is telling us, this diagram. For example, you see in here, in the first bullet point, what do we see? So HTTP unauthorized, let me come here. This HTTP unauthorized has Mule client security as the parent, Mule client security. So HTTP unauthorized could be easy in here under this group and below here. And it has client security under it. And then security is a parent. So it starts here. This is bottom up. When we go bottom up, the error, we have unauthorized, HTTP unauthorized here. Then go up, we get the parent client security, and client security is under security, is what this is telling us. Validation also, you see the structure here, but all of them, they have a parent. The generic or general error messages, the most general parent is in, we see here in. So if you go up here, we get any, and you can go to this documentation and read. So it is detailed, there is detailed information here. And let me show you some of them. For example, domain. So in here, what do we see? The naming config, okay. So see this one. So what it says is the naming convention enables you to distinguish errors according to their domain, like what we said. For example, instead of throwing not found, the HTTP connector, connector can throw HTTP not found, and the file connector can throw file not found errors. So this helps us to understand the different types, and that diagram is here, and you can read more here. And different error types, there are different, it tells us the different error types here. As you build different projects and encounter different errors, you will understand them. You don't need to remember all of them right now, but you see we have under error types, any is a parent, Under it, we have transformation indicators an error occurring while transforming values. We have expression, validation, connectivity, routing, security. And under security, like what we said, under security, we have this client security and server security. Timeout is, I think, clear, and so on. So go over this, and it will give you detailed information. Okay, let me see. Okay, it is almost time. Let's see if we can cover a couple of slides that can help us to have a good stopping point for tomorrow. So in here, so errors can be handled at the following levels. It can be at an application level, at a flow level, at a processor level. So these are what we are going to see with different questions tomorrow. I was thinking we can go up to flow level today, but time flew by very quickly. So this slide, what it's saying is like what we said, to just summarize, when there is, so we see here, when there is an error, there is an error here that you can see, then the error propagates to here. In the error handler, we can have different processors. The processors in the error handler are executed. So we see that what is coming in is red, but what comes out could be green or red. So if it is red, then that means the error is propagated as is. But if it is green, then the error is being resolved and it is going to continue. It is going to give success, and it may continue to the next processor if this error happens in a flow that is being called in a child flow. But if it is in a parent flow, it doesn't continue to the next processor. So in a flow like this, where the error happens in the calling flow itself, then what we are saying is once an error happens in a processor, it doesn't continue to the next part of the component, the processors. Rather, the error propagates to the error handler. And if we don't have an error handler set up there, then the MuleSoft's default error handling will take care of it. And that error gets propagated to the source, is what we said. And we talked about the default error handler, I think. The default error handler here. So if there is an error handler defined, a Mule default error handler is used implicitly and globally handles all messages. If there is an error handler set up, then this one handles safely all types of error messages. And this error handler cannot be configured, but we can create our own custom error handlers, and it stops the execution of the flows. Once the error happens, it doesn't continue to the next processors and logs the error. So we saw this, and let's talk in the next two slides. So we have two error handler scopes. We are going to see these error handler scopes tomorrow, on error continue and on error propagate, when we use them at the processor level, at flow level, and at the application level. How do they behave when we have a child flow and so on? Each one of them, what is their properties, is what we are going to see. But as you can see here, on error propagate, there is an error somewhere, an error happens, and it propagates the error. So we see all processors in the error handling scope are executed. Once the error happens, the error propagates to the error handling scope. So you see, this is the error handling scope, and all of them get executed. At the end of the scope, the rest of the flows that serve the error is not executed. The rest of the flows that serve the error is not executed, and the error is rethrown up to the next level and handled there. So if this is in a child flow, and if an error happens in the child flow, once beyond the processor that serves the error, the rest of the processors, they don't get executed, is what it is saying. And if it is on error propagate, it returns the final response is an error. In an HTTP listener, it returns an error response. So I guess this diagram can help you to remember that. On error propagate, if a processor returns an error, it throws this red or error to the on error propagate scope. And let's say that we have different processors here. We are setting up, creating payload, variable, or status code, and so on and so on. Still, the output from error propagate is an error. So we call this read in and read out. So error comes in through the scope, and error gets out. So this is read in, read out. Read in, remember this. Read in, read out. Whereas in the next one, where in the other scope, when we are on error continue, the same thing, this first couple of bullet points, it is the same. All processors in the error handling scope are executed. So what this means is, if you have different processors in this error handling scope, all of them get executed in both on error propagate and on error continue. Well, so all of them get executed. At the end of the scope, the rest of the flow that serves the error not executed, this is the same as on error propagate. The event is passed up to the next level as if the flow execution had been completed successfully. So this is one difference with on error propagate. So on error continue, it returns a success response, whereas on error propagate, it returns an error. So in an HTTP listener, this returns a successful response is what we see. And see this diagram. So an error happens here. The error gets thrown to the error handler. We have on error continue scope. The different processors here will be executed in their sequence, in their order. But at the end, this returns green. So this is red in, green out. Error came in, but it was handled and it returns success. So when we have this, when we have at application level, these scopes, when we have them at application level versus at flow level or at processor level, what is the final output that we get, or how does the flow, how does the Mule event change? What does its property look like is what we are going to see in detail tomorrow. But I think for today, I have to stop here and take a couple of questions. So let me go ahead and unmute you. So I have many questions at the end, and also tomorrow we will do more than 20 or so questions, different types of questions. So if some of the theory from today is not clear, try to go over the slides. And tomorrow, as we do more and more interactive hands-on demo, you will understand it better.
I have a quick question.
Sure.
Okay. When the error handler read in, read out, the original will be, the reverse will be the return will be the original.
Yes.
When it's green, what will be the return?
Okay. So it will be the last payload.
Green out, what will be the return?
It will be the last payload.
Okay.
It will be the last payload since it is success. It depends on how you configured it in your, if it is HTTP listener, for example, in the HTTP listener, when it is success, the response we put is payload, right? That we saw by default. So when it is success, it should return a status code of 200, and the response is a payload.
Thank you.
Sure. So we'll practice all of this tomorrow in greater detail. So yeah, we'll stop here, not to take much of your time, I think. If you don't have, if you have other questions, I can take other questions, otherwise we'll stop here. And Haptamu and Maazai can stay, and we'll see to fix your error, the errors you have. Does anyone have any questions? So error handling is very important. It is very important. Please spend enough time to understand it. So we'll we have spent 1 hour today, we will spend 2 hours tomorrow, 3 hours, and plan to spend by yourself also practicing at least, I don't know, 5 hours. It depends, on average, around 5 hours, so that you understand it very well. Once you understand it, even if you get questions in different forms, it will not be confusing. But if you don't, if it is kind of your level of understanding, if it is so, when you get an error that is slightly customized from what you saw before, it may confuse you. But it is very interesting concept. Okay, perfect. So the rest of you, please don't miss tomorrow's class. It will be fun. We will have interactive demos and understand it one by one. But for today, this is enough. And I will stop recording.